Yesterday, we have practiced few questions which have been there in JEE Mains in yesteryears. So today also, as I told you, I'll continue with the same thing. All right. Tomorrow we'll do periodic functions, and we'll do that will be the last topic of this chapter. Now, shall we start? Shall we start?
Yes, sir.
Write down a question. So I'm doing again mixed questions on relations and functions. Mixed questions on relations and functions. All right, write down a question. A relation R is given as x comma y such that xy belongs to z and x square plus y square less than or equals to 4. Find the domain of z. Find the domain of this relation. Yes, please. How to do? Find the domain of this relation. Yes, how to do? Any idea? Okay, if I design this relation, I realize the elements here will be if value of x goes 0. Fine, if x is 0, y squared less than equals to 4. So y lies in minus 2 to 2. Am I correct? So in that case, your relation will be having elements 0, minus 2, 0, minus 1, 0, 0, 0, 1, and 0, 2. Then, if value of x is plus minus 1, your y square is less than or equal to 3. So y lies in minus under root 3 to under root 3. In that case, elements will be minus 1, minus 1, minus 1, 0, minus 1, 1, comma 1, minus 1, 1, 0, and 1, 1. Then, if x goes plus minus 2, y square will be less than equal to 0 means y equal to 0. So 5 elements in that case. 2, 0, minus 2, 0. So domain, if you realize, domain goes what? Domain is the set of first entries of the ordered pairs. So it is -2, -1, 0, 1, and 2. So these 5 elements constitute the domain of this function. Am I correct? Am I correct? Is it okay, everybody?
Yes, sir.
Now, write down the next question. Relation R on set A, that is 1, 2, 3, 4, 5, 6, is defined as R is A comma B such that B is A plus 1. Then check for reflexive, symmetric, and transitive. Quickly tell me. Yes. First of all, find the relation and then tell me if it is reflexive, symmetric, or transitive. Yes, quickly tell me. See, the relation here will be 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, and 5 comma 6. Yes or no? Because they have provided B is A plus 1. So second entry is 1 more than first entry. Got it? Now, is it reflexive? Definitely no. Because neither here it is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Nothing is there. Got it? Is it symmetric? Tell me quickly. Not symmetric. Because 1, 2 is there, 2, 1 is not there. 1, 3 is there, 3, 2 is not there. Is it transitive? Again, no. Because if you see at these two, 1, 2, 2, 3, but 1, 3 is not in the relation. Am I correct? So that means the relation is not transitive. Got it?
Yes, sir.
Write down next question. A relation R from 2, 3, 4, 5 to 3, 6, 7, 10, given by x related to y is x is relatively prime to y. Find domain of R. I hope you understand the meaning of relatively prime. Relatively prime means their HCF is 1. They do not have any common factor. For two numbers to be relatively prime, they need not be prime. Like 6 and say 11, they are relatively prime to each other. As a better example, I should say 4 and 9 will be relatively prime to each other. Understood what is relatively prime? Yes. Now see, first of all, I have to make the relation. Now 2 is relatively prime to 3. 2 is not relatively prime to 6. 2 comma 7 will be there. 2 comma 10 won't be there. Now 3 comma 7 will be there. 3 comma 10 will be there. Then 4 comma 7 will be there. 4 comma 3 will also be there. Then 5 comma 3 will be there. 5 comma 6 will be there. 5 comma 7 will be there. This is the relation. Understood? If I talk about the domain, domain is the collection of first entries of the ordered pair, that is 2, 3, 4, 5. So entire domain set is the entire set A. Am I correct? Am I correct?
Yes, sir.
Write down another question. Let P be the relation. Let P be the relation defined on set of all real numbers. Set of all real numbers such that P is what? A comma B such that secant square A minus 10 square B equals to 1. Then P is. Options are again same for you. Reflexive, symmetric, transitive. Tell me what is P. This is such a good question. Yes.
अच्छा वो जो बड़ा सा
जिसके 70
जिससे 72 क्वेश्चन हो इनको भी दिए हुए हैं।
Yes, done. Okay. First of all, if I check for reflexive, see, is A comma A belong to relation? The answer is yes, because sec square A minus 10 square A is definitely 1. Correct? So this relation is going to be reflexive. Now, is it going to be symmetric? Let A comma B belongs to relation. That means sec square A minus 10 square B equals to 1. This sec square A को I can write 1 plus 10 square A minus this 10 square B को we can write secant square B minus 1 equals to 1. So this comes out to be 10 square A minus secant square B equals to minus 1. If you multiply it with a negative sign, so if you multiply it with a negative sign, it will become sec square B minus 10 square A equals to 1. Correct? That means B comma A also belong to relation. Am I correct? So this goes symmetric. Now, if I talk about transitive, so symmetric it is transitive. Let A comma B and B comma C belongs to relation. That means sec square A minus 10 square B equals to 1 and sec square B minus 10 square C equals to 1. Correct? Let us add both of them. So sec square A minus 10 square B plus sec square B minus 10 square C equals to 1 equals to 2. 1 plus 1 is 2. This sec square B minus 10 square B also goes 1. So sec square A minus 10 square C plus 1 equals to 2. So secant square A minus 10 square C equals to 1. That means A comma C also belong to relation. So this is transitive also. Such a good question, heavily conceptual. So this is an equivalence relation. Am I correct? Is it fine? Tejaswini, understood beta?
Yes, sir.
Very good. Write down another question. Relation R given by x comma y x square minus 3xy plus 2y square equals to 0 for every xy belongs to R is, again same question, reflexive, symmetric, transitive. Tell me quickly. Yes. Just quickly try. Well, see, if I talk about reflexive, is x comma x belong to relation? If I do x comma x, I get x square minus 3x square plus 2x square, which is a 0, which is actually true. That means every x is related to itself. So that means it is reflexive. Now, if I talk about symmetric, see, if x comma y belongs to relation, that means x square minus 3xy plus 2y square equal to 0. So I cannot say that 2x square minus 3xy plus y square will also be 0. That means y comma x does not belong to relation. So it is not symmetric. Now, if I talk about transitive, how will you check transitive here? You can see any example also. Since it is an objective question, we can see an example also simply. Now see, let us take some value of x. Got it? Like 4. If I take x as 4, what do I get? I get 32 minus 6y plus y square equal to 0. No, 4 3 is 12, sorry. 32 minus 12y. Now, 12y plus y square equal to 0. 16 and 4. I'm doing some mistake. Sorry. If x equals to 4 x equals to 4, I get 16 minus 3xy means 12y plus 2y square equal to 0. Now, if you realize y equals to 8, y equals to 2 is satisfying this. That means 4 comma 2 belongs to relation. If I put now x as 2, I get 4 minus 6y plus 2y square equal to 0. So y square minus 3y plus 2 is equal to 0. So y equal to 1 is satisfying. That means 2 comma 1 also belong to relation. Now you have to check, is 4 comma 1 belonging to relation? Put x as 4 and y as 1. X4 means 16 minus 12 plus 2. No, this is non-zero. That means 4 comma 1 does not belong to relation. 4 comma 2 does not belong to relation. So it is not transitive. So that means relation is reflexive, but neither symmetric and nor transitive. Am I correct? All of you understood? Now, let's go further. Let a function f defined from R to R is given by fx equals to e to the power 2x minus e to the power minus 2x upon 2. Then, first part, A option means f is many one. B option on 2. C option, f inverse is half of log x minus under root of 1 plus x square. And D part, f inverse x is equals to half of log x plus under root 1 plus x square. Yes, give it a try quickly. Yes. See, let me do this for you. What is the fx you are having? E to the power 2x minus e to the power minus 2x upon 2. So in that case, f dash x will be 2 e to the power 2x minus e to the power minus 2x into minus 2 whole divided by 2. So it will become e to the power 2x plus e to the power minus 2x. Yes. Now they both are positive. So I know this value is more than 0 for every x. Now the value is more than 0. That means what? Function is always increasing. Is it okay, everybody? If derivative is more than 0, that function is always increasing. And if the function is always increasing, that function becomes what? Tell me, 1, 1 or many 1? Tell me. So that means function is 1, 1. Now, if you realize, if I do x approaches to infinite fx, this will be limit x approaches to infinite e to the power 2x minus e to the power minus 2x by 2, which will approach to infinite, because e to the power infinite will become infinite. If I check for limit x approaches to minus infinite fx, it will be limit x approaches to minus infinite e to the power fx minus e to the power minus 2x by 2, which also approaches to minus infinite, because now this will play a leading role. This will be minus e to the power infinite, which will make it minus infinite. So the function is going from minus infinite to infinite and always increasing like this. So that means it is onto. Got it? Now 1, 1 sorted, not it is 1, 1, not many 1. It is onto, not into. Now since it is 1, 1 onto, since it is 1, 1 onto, function is going to be invertible. Function is going to be invertible. Now see, I know that let e to the power 2x minus e to the power minus 2x upon 2 is y. Now what I have to do, I have to write x in terms of y. So I write it e to the power 2x minus 1 upon e to the power 2x is equals to 2y. So it will become e to the power 2x whole square minus 2y times e to the power 2x minus 1 equals to 0. So e to the power 2x will be what? 2y plus minus under root of 4y square plus 4 upon 2. So it will be y plus minus under root of y square plus 1. Got it? Now see, e to the power 2x, it is a positive quantity. Yes or no? If it is positive, so right side should also be positive. That means that negative sign should be rejected. Yes or no? Because if you keep the negative sign, y minus under root 1 plus y square is definitely going to be negative. So that means e to the power 2x is y plus under root of 1 plus y square. So 2x is what? ln of y plus under root of 1 plus y square. So x is what? Half of ln of y plus under root 1 plus y square. Correct? And this is what we call f inverse y is half of ln of y plus under root 1 plus y square. So since we are used to see everything in terms of x, this is half of ln of x plus under root 1 plus x square. This is the inverse of this function. Got it? So this is also a correct answer. Very good question. Have a look at it. Have a look quickly. Got it? Now, write down the next one. Let f from A to B defined by fx equals to 2x upon 1 plus x square. F from A to B, 2x upon 1 plus x square. If this fx is a bijective function and A is -1 to 1, then find B. Yes. Are you guys comfortable with the kind of derivative we are using? Tell me. Just tell me quickly. Now see, the function we have is fx equals to 2x upon 1 plus x square. Okay, I am asking you, are you guys comfortable with the kind of derivative I am using? Hello? Okay, Lakshmi said yes. Okay, so if I do differentiation here, that is square of the denominator, derivative of numerator is 2x minus numerator, derivative of denominator is also 2x. So it is 2x plus 2x cube minus 4x square upon 1 plus x is, sorry, just a moment. Derivative of numerator is 2. Now if I take 2 common, so 1 plus x square minus 2x square. So it is 2, 1 minus x square upon 1 plus x square. Correct? Now, if this 1 minus x square is less than 0, 1 minus x square is less than 0. That means if x lies in -1 to 1, which is my domain in the case, this f dash x is going to be more than 0. See, denominator is always positive. And numerator is 1 minus x square. So that is also going to be positive. Or sometimes 0. That means this numerator is always positive. So function is always increasing. Now function is always increasing. So in that case, f of 1 will be the maximum value and that value will be what? 1. F of -1 is going to be the minimum value, that is going to be -1. So range is what? -1 to 1. Range is -1 to 1. Got it? So set B is going to be what? -1 to 1 because you are going to make this function bijective. Am I correct? All right. Now, for next couple of minutes, please speak up if you want to say anything. And I'm going to see what we have done today. Fine. We have done this question on relations. Then anybody facing any difficulty in any question, just stop me right then and ask. Anybody is having any problem with question number 1? Have a look. Quickly. Anybody having any difficulty with question number 2? This question. Anybody would like to ask something in question number 3? Quickly, please tell me. Anyone who would like to ask in question number 4? Have a look. This is a very good question. Lakshmi, you understood question number 4 completely?
Yes, sir.
Tejaswini?
Yes, sir.
Very good, bacha. Gautami, you got it? Karthik, understood?
Yes, sir.
Very good. So proud. Question number 5. Anybody for anything reflexive symmetric transitive? Question number 6. Anyone? Anybody for question number 6? Question number 7. Anyone? Lakshmi?
Yes, sir.
आज के questions में which question you find as the very good question?
Sin square theta minus tan square theta.
Sec square theta. Okay.
Yes, sir. That one.
But you understood rest of all the questions?
Yes, sir.
Very good. Very good. Nirali? Tanush? Tanush?
Yes, sir.
Why are you disappearing again and again?
Sir,
Huh?
I went to another class.
Okay. All right, guys. Thank you so much. Study hard. Tomorrow I'll explain you about the periodic functions. Fine. So we'll do that. Then day after tomorrow, we'll do more questions which have been asked in JEE Mains yesteryears. Fine. Thank you so much. Enjoy your day. All the best.